Welcome to the Quick Start video for the last unit, the Independent Final Project. Here's what we'll cover. We'll introduce the learning goals and unique features of the unit. We'll call your attention to key preparation and recommended additional materials in Lesson B. And we'll summarize each lesson's main activity, also focusing on Lesson B. Now, it'll be helpful to have the unit materials open as you watch so you can pause to look at them in more detail. So during this unit, students will code a unique original program and design and build a physical maker component that uses the microbit in some way. They'll demonstrate what they know and something new relating to at least one of the concepts of Units 7 through 12. So coordinates, booleans, bits, bytes, and binary, radio communication, arrays, and finally the accelerometer. Now, like Unit 6, the mini project, the final unit has students focusing on synthesizing their new skills and engaging their creativity. So your students are going to spend the majority of their time on project design and development in Lesson B. And we've provided some recommendations about class structure for Lesson B, including, spending some time actually having students test each other's projects while they're in the process of being made and giving people feedback, taking feedback and iterating on your design, keeping work logs to chart their progress, and also records of thinking, which are kind of like journal entries that sort of look at the work logs and come to some conclusions about how their learning is progressing. And then finally, Lesson C is going to be our final project showcase. Now, in your preparation, you may need some advanced planning for coordinating the showcase option that you choose for Lesson C. So, for Lesson A, your only preparation really is going to be printing out the exit tickets. And then for Lesson B, you've got some decisions to make. So you're going to want to review the class structure recommendations and decide how you're going to incorporate them. You'll want to take a look at the notes about project scoring, work logs, records of thinking, and determine any revisions you might want to make. You might want to decide how your students are going to turn in their work logs and their records of thinking entries, considering the provided ideas. And then, because the students actually start their project in Lesson B, you want to make sure you have all the needed hardware and crafting supplies restocked. And you'll want to have the optional hardware if students are going to incorporate sound or motion in their projects. You'll need things like servo motors and things like that. But again, the final project can just be the scope of the amount of time that you have to devote to it and the types of resources that you have available. And kids can just work within those parameters when they design them. So now for Lesson C, we've given you a note to kind of decide how you want to organize this showcase and if you want to invite parents or administrators to attend, which is always a great idea because that way they really get a sense of what's going on in your classroom, and it's dynamic and it's exciting and the kids are excited. It's really a great showcase for the great work that you've been doing all year. So I suggest that you probably want to post the narrative questions or email them to a shared drive so that you can make it easy for students to turn in their work electronically. And then you'll also want to coordinate the location and the setup. Now for Lesson A, you'll just give a brief overview of the final project, and you'll want to facilitate some kind of concept review activity, and then maybe have a group brainstorm where students sort of just throw out different ideas. No commitment necessary, but just any ideas that they have, the crazier the better. Just throw as many ideas out there as you can for potential final projects, and then you can make like a shared pool and students can choose. I also will let students choose the same idea as long as they work separately on their projects, and it's often really neat to see how kids interpret the same idea but in several different ways. Now in Lesson B, you have students using the design thinking approach to code and build a project that shows what they know, shows something new, and also includes some kind of a physical maker component, maybe something with cardboard, or it has to be something where the physical component is an integral part of the project. It can't just be they have the microbit, something's happening in the microbit, and they tape it to a board. It actually has to have part of some functionality that coordinates with the microbit. So part of those expectations that you would have would probably involve sharing the time frame, which is likely going to be a number of class sessions and maybe additional responsibilities for students to document their progress with their work logs. And you'll probably also want to have them record their learning and record of thinking along the way. We have information about that in the Educator Guide. And their overall learning after Lesson C. So the intention overall is you want to provide kind of a 50-50 assessment of the process and the final project itself, so that you're not placing the bulk of it on the end product. We really want to assess and give students feedback on their learning along the way, because the process is where that learning takes place. And again, all that information is in the Educator Guide. Now, we have some potential ideas for inspiration and some pretty cool examples. So for example, a baseball pitch counter that uses the microbit's accelerometer to record thrown pitches, a step counter of some sort, and a compass that kind of updates as you walk around. This one is a microbit violin tuner that kind of displays the note that's being played. This one is a trumpet angle detector that a student designed for marching band practice, where players need to hold their trumpets at a specific angle to avoid hitting the person in front of them. So they attach the microbit to the trumpet, and it displays a check mark or an X to help new trumpet players kind of learn what the proper angle feels like. So for Lesson C, you'll facilitate the showcase celebration for students to share their final projects with one another, and any showcase guests, other teachers, parents, administrators, and invite everybody. It's a lot of fun. So thank you for bringing Introduction to Computer Science with Microsoft MakeCode and Microbit to your students. You've really opened their eyes to the creative possibilities of coding. You've helped them build a foundation of computational thinking skills, and you've motivated them to keep learning. And I hope you and your students feel incredibly proud of the work you've done all year. Congratulations.